There's a lot of moving parts in this live demo, so I probably have a live demo, and we'll see how that goes. Hi, I'm Lorna. I'm a developer advocate at IBM, which means that I mostly play with databases on the cloud, but you've got to connect to them from something. So this seems like a great excuse for me to explore serverless, and I've really enjoyed the stuff that I've done with that. I rashly titled my talk Fun with Serverless Apps. So as well as telling you about, yes, this is how you do serverless, you should run this command and write some code, I've got to try and do some fun as well. This seemed like a really good idea at the time. So I pop her out a bit. This is an Amazon Echo Dot. It was connected to the Wi-Fi earlier. And the idea is that she will be part of this presentation and show you some of the things that you can do. So we'll just see if she's working. Alexa, hello.
Hi.
We're off to a good start. Alexa, how are you?
I'm great. I hope you are too.
We are set. All right, so let's talk about the serverless revolution. And there's a big secret to serverless, and that is there are servers. Quite a lot of them, actually. It is the silliest name in the world. It's a bit like no ops, which is possibly the best ops you'll ever see, just done by someone who's thought about this more than you have. So the idea with the serverless stuff is that while DevOps has been the buzzword for a while, we are now somewhat specializing in what we're good at. So we're bringing the dev and the ops a little bit further apart, making the ops even more awesome, and allowing the developers to really focus on just the functional parts of what they need to do. Full disclosure, I am definitely on the dev side of this fence. I'm a server-side developer, and I probably always will be. The idea here is I'm going to speak mostly about functions as a service, which is kind of a subset of this whole serverless idea, because serverless can cover other things. Functions as a service really means for developers to think about what it is they need to deliver, what the dependencies are for that, so the outputs, the inputs, and then the easy part, the code that goes between here and there to allow us to do that. So it lets us really focus just on small pieces of functionality, and it encourages us to keep all of the different pieces of our system small and isolated. And small, isolated pieces are what makes the magic in truly scalable distributed systems. This isn't just another buzzword. We see a lot of buzzwords in tech. Things, I don't want to name and shame anything because I'll get flamed on Twitter, but things come in that I just think, yeah, I don't need that. With this, I feel differently about it. It is a different approach to development. The billing is measured usually in gigabyte seconds, so it's units of a process running for a second with a gig of RAM. A lot of them don't run for a second or use a whole gig of RAM, but that's kind of the units that we use. So you usually see very small numbers because you can do a lot of serverless stuff before you start to run up any kind of bills. What's interesting about that is, and Simon just really mentioned this really clearly about being efficient with our code, being able to spot which of the small components is incurring most of the cost. If you can work with resource-restricted code efficiently, then you are going to go far in this. So it's almost going, nothing new is anything but old, right? If you can remember a time where we didn't just run full-stack frameworks for no reason and take several seconds to bootstrap thousands of dependencies, right? Then we're almost going back there, keeping it very simple and very performant. If you are one of those people who still writes branching instructions the correct way around for instruction pipelining, those skills become valuable again. I am ethically in objection to telling you anything about how to write serverless code until I try and tell you when you might want to. It's not a silver bullet. You're not going to use it for everything. But here are my favorite use cases that I'm seeing really good results with. So if some of this applies to you, then you can probably start to think of some specific applications where you might want to try this kind of tech first. A very simple and easy use case is to not need to run a server for a mostly but not completely static site. So I'm seeing a lot of serverless endpoints for registrations, contact forms, inquiry forms, those kinds of things. You can deploy your proper static site and have on it a form that posts to a serverless endpoint and have that do the work and write to the database or send the confirmation email or whatever you need to do. If you have very variable traffic levels, I've used the IoT sensors problem as an example because it's one that I'm familiar with. They instrument a whole block of flats and then turn it on and the server falls over. Oops! So, okay, you need queues in the face of a problem like this as well, but using the serverless approach will allow you to kind of scale up just as big as it gets. If you don't know how much of your compute resource you're going to need, then, or if it could be a lot in one moment and not so much in the next, this is quite a nice use case, and it certainly helped me when I had that as an engineering problem. I am also seeing quite a large number of organizations feel their way by touching the stones, right? I'm seeing them going a little bit serverless, going hybrid, either adding functionality or refactoring to serverless on an existing application. Please don't feel like you have to wait for a brand new application, greenfield, start from scratch with a whole new approach. Serverless will fit in around what you're doing. It's useful in lots of ways. You always see the image resizing or the PDF generation as the classic example. But that's because it's actually quite a good use case, and that's why we keep using it. It's work that needs to be done, but you don't necessarily want it running on the web tier. That's why that's there. So, okay, now we'll start to, I'd like to show you around, give you a sense of, as a developer, how you approach this. I've got some fairly simple examples so that we don't get bogged down in the examples, but I want to show you around how this looks and how the simple stuff works. So I'm going to show Amazon Lambda and OpenWhisk. I've worked with both, although I'm at IBM, so I have a do-what-you-like account with our hosted OpenWhisk. So, you know, that's kind of compelling. OpenWhisk is also an open source project. So whether you want to use a hosted offering or run it locally for dev platform to play with, or within your own server stuff, then that's also fine. So for Lambda, you will need to install the AWS CLI package. It's called that on most, but not all platforms, because that would be much too easy. And that gives you an AWS command that you can then use to do AWS type things. Notice that I've just said you should set up the permissions. I'm skating over quite a big issue here. If you are Amazon native, then you will probably want to try serverless with Lambda, but you will already know how to work the IAM stuff. I had to have help. The permissions you want are Lambda, API gateway, and CloudWatch logs would be my recommended starter set. And once you've got that role set up, then you can configure it on the AWS tool with AWS Configure. Then we do the easy bit, which is write some JavaScript. All of the different serverless platforms support different languages, and probably you're not all JavaScript programmers. I shouldn't probably say that it's the lowest common denominator of the web, but JavaScript is widely used and fairly easy to read, so hopefully the examples will work for you regardless of what your native language is. And for the purposes of this, I'm going to zip it. I'm using a simple JavaScript file, and I'm just zipping that, but I tend to zip everything because if you need to zip extra dependencies, then the process then looks the same. So we create our hello.zip because my action is going to be called hello, and then we ask the AWS command line tool to create it for us. You can do everything you're seeing here on the command line through the GUI interface. So if the command line stuff isn't the way you normally like to use a computer, there are definitely alternatives. But once you get up and running, you're going to want to use the command line stuff because it makes your cycle time quicker. I am also command line native, so I don't really use the GUIs for anything. So we're going to create a function. The function's got a name. It's got a runtime. There's the I am stuff that I set up, and a description, because in your Lambda dashboard, you'll see a list. A handler, this is the entry point. So we're going to export this in index.js. It's called handler. We're going to export this. This is how the code will know where to begin, what to run. And I'm supplying the zip file with that file b : / thing. You can also upload to S3, and there's a bunch of other options, but this is just supplying the file. Once you've done this once, and then you've iterated, so you've rewritten your JavaScript, and then you've zipped it, you'll want to use the update function code instead of create function. There's also update function config, should you need to do that. Once it's up there, you can just invoke it from the command line like this, and it will come back and say, hello world. It probably gives you some status response as well, all dumped into that output.txt file. So what is this mysterious code of which I speak? Well, I hope you can all read enough JavaScript to keep up with this. If you can't read the font, then just check the conference hashtag. I've tweeted the link to my slides. They're already uploaded. So if it would be easier to read it in front of you, please do that. OK, so we export our handler. It's a function. All the Lambda functions have a signature like this. So we've got the event and the context. The event is what happened that caused us to want to run this serverless thing. And the context is where we indicate our outcome. You can get some other metadata from the running process as well, like how long it's been running and stuff like that. I am just saying it's good and sending a message. Everybody still with me? Good. Excellent. So using different serverless platforms requires slightly different coding approaches. For example, that's the Lambda one, but this is the OpenWhisk one. It's very similar, but subtly different. So here I'm exporting a main function. That's the default entry point for OpenWhisk, but you can override it with an entry in package.json and then just include that in your zip file. The OpenWhisk just accepts args. And what you'll get there is parameters that are set on the package or the action, more about packages in a minute, or arguments that came in when we invoked the function. You can pass in some variables. If it comes in on a web route, there might be some parameters in that request. So they will all come here, and you can pass that to get that information out and know what to do. Then you need to return an object, like so. If you are not terribly keen on locking yourself into one platform or another, then good. A lot of the time, people are looking at, like if you're already in the Amazon ecosystem, then you're probably going to deploy to Lambda anyway. If you are more picking and mixing the right cloud services for what you need or running your own, OpenWhisk is a good option, but there are plenty of hosted providers that you'll hear more about through the day. What you want to look up is something called the Serverless Framework, which aims to make both this, like the subtle differences between the JavaScript wrappers, and the commands to deploy it work the same across the different platforms. So that allows you to create something that is a bit more vendor independent. It's an active project. It's awesome. Some of the contributors are here. So I have a link in my slide deck right at the end, so look out for that. All right, let's have a look at the mechanics then for running this OpenWhisk JavaScript in a serverless manner. You're going to need the WSK, the Wsk CLI. The easiest way to do that when you're logging into hosted Bluemix is to just click on the download CLI button. It sets all your auth key and everything for you. And then you can, again, I'm zipping my code and just creating an action. With OpenWhisk, if you run update and it doesn't exist, it'll just flip it to create. So you can just always run the same shell script all the time. And it'll create if it didn't already exist. It'll just make the thing that you've asked for, which I quite like. Here I've called my action demo/hello1. And that demo is a package name. So when you work with OpenWhisk, you can create packages. Your actions belong to packages. You can also set some parameters at the package level that all the actions are able to access. So what I normally do is the continuous integration system will deploy all of this and set things like the API key for the Slack notifications and some of the database creds and stuff are all set on the package level. So any actions that need those can access those in some of the other apps. Invoke it like this, and on OpenWhisk, we do have a detailed API gateway which allows you to set pretty routes and all sorts of other stuff. But for just, I would like to be able to call this endpoint with HTTP. You can do this --web true in your update command, and it will just give you a route, which will be, it's the API, the account, so that's my account, the workspace that I'm using, the package name that you've just seen, the action name that you've just seen, .json. I tend to leave it just like this. If it's, a Slack command hooking in, GitHub webhook, whatever, tend to just use these endpoints as they are because it's so quick and easy to set up. Hopefully you're starting to see this isn't exactly rocket science. The JavaScript files are 3 lines long. There's like 2 commands on each to get it working. You could literally get this going in your lunch hour. And if you'd like to do a little workshop with me in your lunch hour, you may. And now I've shown you the web routes, and suddenly we've got a magical combination of independently deployable code pieces, ways to access those over HTTP, and I hope you all have your bingo cards ready because suddenly it all looks a bit like microservices. That we have these small pieces of functionality that we can web reach, and we can see how this underlying technology allows us to adopt some of the bigger ideas that we're hearing in our industry. I never talk about microservices without showing the good old service-oriented architecture diagram. If you were in IT about 8 years ago, this was the new hotness. Your shiny, amazing, brand new cutting-edge mobile website would share code with your desktop website. Like the application code would be the same, and we'd have like common functionality, and this was new. And this service-oriented layer would then also manage all the access to storage. I've third-party APIs, I've got a GitHub icon on there. We draw microservices as hexagons. If you were to simply honeycomb the middle bar in this diagram, you would be drawing today's software architecture perfectly well. So thinking about that service layer as individual services, and we have the technology and the architecture ideas we need to build modern componentized systems. I have a horrible feeling you didn't come to hear me talk about modern componentized systems. A horrible feeling you're hoping to talk to her instead. So let me introduce. Did I mute her? No, I didn't mute her. So I will try not to speak about her by name. It's an Amazon Echo Dot. And the idea is, if you may have one of these at home. Does anyone have one of these at home? Yeah? Oh, wow, okay. So this is a gimmick, but I think it's an adorable way to just have a really nice front end and kind of get to know some serverless tech, right? Because this one-off, rare use pattern, perfect for serverless, whether you run it on Lambda or on OpenWhisk. I have both, so I'm very inclusive today. I speak, she listens, sends it to the cloud, it parses it in a mysterious way, decides what to do, does that, and sends back some words. So here is an example. My example is called Project Codename. There's an NPM library that does this. It generates a random project name. Obviously, you need a good code name if you're going to start a new project. So there's an NPM library that does that, and I can command Alexa to generate one for me. I did say her name, but she didn't hear me. OK, good. So we need to say some magic words, and I'm happy that Simon mentioned the BLA template approach. That's basically what she does. And what happens here is that the Amazon Echo expects you to say, ask, or tell. And this first BLA word is the invocation name, or the skill name. A skill is like an app for the Echo devices. You can go on a marketplace and choose one and plug it in and enable new skills on your device. So the first word is the invocation or skill name. And then you say exactly what you would like that skill to do. Because if your skill is book a table, it might be tell me when my table is, book a new table, find out what tables I could book. So the next thing is the intent. So which function within the skill should we do? And then sometimes you'll also have extra stuff like slots. So this might be a table for 4 on Wednesday at 7:30. So there's a bunch of different slots. Seems to be a big word for variables. So I can invoke her. When I'm configuring the skill needs a name, and then make sure you have your language and region set up correctly, or your skill will work perfectly in the test framework screens and not at all on your device for no apparent reason. Guess how I found that out? So it's here, in case you're following my instructions. If it's not working, check the region and language. And then you set up an endpoint. You can either create a new Lambda endpoint, and there's like a web text area you can type JavaScript into if that's how you like to write code. Or you can do the stuff that I've already showed you for uploading code to a Lambda endpoint, or mine's deployed to OpenWhisk. You can give it a web URL. Once it's set up, then you need to configure the utterances, the things the human will say to cause the device to understand. So it's very formulaic. There's no like funny, amazing natural language processing going on here. It's literally BLA templates. So you can configure like this with an utterance and the words the human will say. So I don't have to remember exactly the right words when I want a new project code name. I just need to get approximately one of these. And it's also got some storage in it. So because I play with databases, it obviously stores it to Redis. So if you don't quite hear her the first time, you can ask her to say it again. Clue, if she embarrasses me with this or randomly generated wording, I'm not going to ask her to say it again. Okay. Recently, they've released this interaction builder, which is like a more GUI way of doing this, and is a much better way to configure slots. I'm going to talk more about slots in a minute. Let's have a look at the code for the project codename generator. Require the library, generate a random codename, return the response Alexa expects. She's still not listening, good. Return the response the device expects. So all we need to do is set the version that we're using, send a response. Should end session means we've finished talking now. Like no further, she shouldn't wait for me to say another thing. And the type of response here is plain text. There is a way of doing marvelously expressive speech. I'm a server-side developer, so I haven't done that, because I don't, feels like presentation layer. So, obviously it's a serverless function. It's running on OpenWhisk, and I can invoke it from the command line. I can also invoke it by voice. Alexa, ask project code name for a new project name. Alexa, ask project code name for a new project name.
Project code name, Vogue, guitar.
Interesting. Alexa, ask project code name to say that again.
Vogue, guitar.
There we go. So I think the echoes are getting to her a little bit. So we can very easily have her do the invocation of our marvelously technical serverless skill that we all came here to talk about. We can do more advanced things with Alexa as well. She can carry on a whole conversation. So I said the variables were called slots. So you can say to her, like, ask the meeting manager app to set me up a new meeting. And it'll come back and say who should be at the meeting, what day, what time. And you can try and supply all of those in your initial words, or you can just let her ask you for all the pieces of information she needs. So you set up a slot, set the data type. She knows if you're going to say a number or a date, and she's quite good at parsing those. She can do like next Wednesday and things. And you can also set a bunch of different ways that she can prompt you for that information. which is nice. It just makes her a little bit more like a conversationalist. I mean, she's obviously not, never worked with children, animals, or robots. Except I did, but never mind. So you can kind of give a choice of ways for her to do it. But in my example, I need to generate the question because it's a quiz question. So I am going to ask her to ask me a maths quiz question, and then I will answer it. But the question obviously changes every time, so I can't hard code that. What I do is I create an intent. I've stuck it inside my existing Lorna invocation so that I don't have hundreds of things to remember. And it's got one slot, and it's called number, but it's the answer to the maths quiz. So I need to generate the slot prompt as well, and then have her come back to me. If you have slots where you can hard code the questions, you can just say, do the rest of the dialogue. So you'll get the initial request with variables missing, and you can say, ask for the rest of the variables. And then the ecosystem itself will just go through and see what's missing and fill in the gaps and come back to you once it's got everything. Because that means that you're having like a multi-stage conversation, almost like a web browsing session. Like, we've probably solved this problem before. It's got a session that you can write to. So you can write to this session, and then it's there the next time the same device comes in with the next request until you end the session. So it's sort of during the conversation we store state. So the quiz goes something like this. It's on the slide for backup reasons, but we can ask her, Alexa, ask Lorna for a quiz.
Ready. What is 2 plus 5?
7.
Sorry, I didn't understand. What is 2 plus 5?
7.
Well done. 7 is correct.
Woo! That was quite fun because she didn't understand me. And so I obviously have a case for that, where it comes back and it goes, you have a question mark in your value field. I'm just going to ask you that again. Like, she doesn't understand. So this is how it works through. And if it's wrong, she'll say so. If she didn't understand, she'll prompt me again, which you just saw. And if it's correct, she'll be like, way. So first of all, try not to say her name, right? I prompt her for the skill and intent that I want. And what I get in is this. So I get a request that says, this is a new session. The intent is quiz. I've got a slot. The number is there. I've got a field, but I've got no value. It's got a name, but no value. So I know that the person hasn't supplied the answer. How would that even work on a new request? So then I return a response saying, with the device asking the question. So I'm filling in that slot. I send the words that I want to say as the speech output, and then I say send the elicit slot directive, and it prompts for this slot with these words. So if you need to control that conversation, this is how you do it. I also write to the session at this point. So I write the question, because she might need to repeat it if she didn't understand me. I also write the answer to the question, because these were two randomly generated very small values, so that I would be able to add them together even on stage. So I store the answer as well, so we know when we're right. So she prompts the user for the slot, and what comes back is, it's not a new session, we're still with the quiz intent, but my number slot, with some apologies for the white space crimes that I used to get this on this slide, I didn't think it should be any smaller. I've got a value now. So the value is a number because I described my slot as being numeric. If you try and give her nonsense answers, she'll almost always try and hear them as a number, which is, well, I've been testing this a lot and it's hilarious. And once it's correct, all I need to do is send the output text as I did in the project code name. So what I'm trying to achieve with this, and feel free to come and have a play later, like it's quite fun. We don't have to have it plugged into the whole sound system if you don't want to. What I'm trying to show you with this is a bunch of you already own one of these devices. They're inexpensive. It's relatively simple to write the code. The project codename code you've seen, I would say in its entirety, no, because I added Redis support, so it doesn't fit on one slide now, but it is all on GitHub, so you can just grab it and try it on your own apps and then start editing stuff. The quiz one's online as well. It's really approachable. Maybe this seems like a big concept. Maybe you're going to hear some long words today, but a developer of almost any background and any level can find a way in with serverless stuff. I said at the beginning it was a gimmick, and it is. But it's also a fun and approachable way to pick up new skills. I've enjoyed it. I've gone on and built some more serious, bigger internal tools that move data around and do stuff. But I learned the very beginning and how the mechanics work of moving the code around and how to debug it, all from playing with something like this. So that's kind of where I'm aiming to go with this, just to show you around and hopefully give you a little bit of momentum to try it out for yourselves. I think the serverless movement is a revolution. It is a big change in the way that we do things. It's as important as moving from buying physical hardware and renting data center space for it to kind of renting that already for you to getting VPSs and not really caring where they are or if they move. This is the next step in that progression to having such good operations and orchestration. And the technology has unlocked this. All the movement to containers is what enables the work that we're doing with serverless today. I think it's a sea change. I don't think it's the right answer for everything we'll ever build, but I think you'll see more and more of it. I'm really pleased to see events like this, and there's a bunch of you here, really pleased to see events like this and see us sharing what we're doing. It is early days, but it's the beginning of a really, really big change. And hopefully what I've shown you today has made it seem closer for those of you that haven't already had a shot. I am pretty much at the end of my slot, but I will I've tweeted these slides. You don't need to photograph it. I have tweeted these. There's some resources here for you. I also blog a bunch about this, and I have some more posts in the queue, so check out lornajane.net. Tweet at me, talk to me, whatever you want to do. I'm really, really pleased to chat, and I'll be here all day and into the evening event as well. And with that, I'll just say thanks for your attention.